Hello everyone. In my previous videos, I have written the code of Verilog for D latch with synchronous and asynchronous resets. And here I am writing the code of D flip-flop with synchronous reset. So let's get started. Module D flip-flop, D input, clock, reset and Q. Input D, clock, reset. Output Q, register Q, then always block, positive edge of clock. So here positive or negative edge of clock will be required because we are dealing with the D flip-flop, not with the D latch. In D latch we required level triggering. Begin Q. If a reset occurs, then our Q will be assigned to 0. Else our Q will be assigned to D or it follows D. Writing a test bench for the code, that is module D flip-flop test bench. Register D, clock and reset, wire Q, D flip-flop test bench, module instantiation, clock reset Q, initial begin, initializing the initial values to 0, inputs to be 0 initially, reset equals to 0, $dump file for showing of the waveform, test.bcd. $dump vars. Hash. After this much of time unit, our code execution will be finished. And giving inputs, hash 3, D will be toggled after this much of time, then always hash 5, clock will be toggled, always hash 20, reset, duration of reset, and module selecting simulator and running it. See this again we haven't initialized Q equals to 0, so this is the high impedance showing this red mark. Initializing Q equals to 0. See, this is our waveform. When our resets occurs, our data will be 0 but on the S triggering when at the edge of the clock. See, when edge of the clock arrives, our reset will function. Whatever the data will be stored or follows, it will be 0. And rest of the time, see in this edge, data will be 1, so our output will be 1, and it follows until the next clock edge. When it arrives, our data will be 1, so it follows again until the next clock edge. Here it is reset, so it will be 0 up to this much of mark. When the again next clock edge arrives, it follows D and it's go